Plastic is everywhere. It's in our homes, our cars, our smartphones, our clothes, and even in the air we breathe. It has revolutionized industries and made modern life more convenient and affordable, but at a staggering cost. Every year, humanity produces over 400 million tons of plastic, and nearly half of that is used only once before being discarded. Of this massive output, only around 9% is ever recycled, and the rest ends up in landfills, incinerators, or worse, floating in the oceans, poisoning marine life and breaking down into microplastics that have now been found in human bloodstreams, placentas, and even the deepest. Beyond the visible waste, plastic production itself is a massive contributor to climate change, accounting for more greenhouse gas emissions than the entire aviation industry. Most traditional plastics are made from petroleum, and the extraction, refining, and production processes involved are energy-intensive and carbon-heavy. As the world battles rising temperatures, intensifying storms, water scarcity, and ecosystem collapse, the need for alternatives has become more than urgent, it's existential. Enter bioplastics, a fast-growing field that promises to replace fossil-based plastics with materials derived from renewable biological sources such as corn starch, sugar cane, algae, potato peels, even food waste. At first glance, bioplastics seem like the perfect solution: plant-based, often biodegradable, and capable of breaking down in months rather than centuries. But as with most climate technologies, the reality is more complex. Bioplastics fall into two main categories: bio-based plastics, which are made from renewable resources, and biodegradable plastics, which can decompose under certain environmental conditions. Some bioplastics, like PLA polylactic acid, are both bio-based and biodegradable. Others, like biopet, are made from biological sources but remain chemically identical to traditional plastics and don't biodegrade any faster. The appeal is understandable. Imagine packaging that disintegrates in compost instead of clogging oceans for generations. Yet, not all bioplastics break down in natural environments. Many require industrial composting facilities that maintain specific temperatures and humidity levels. Without such facilities, these materials can persist just like conventional plastics. Worse, if they break down in landfills without enough oxygen, they may release methane, a greenhouse gas over 25 times more potent than CO. Then there's the issue of land use. Producing bioplastics from food crops raises ethical and environmental concerns. In a world already struggling to feed billions, dedicating arable land and water to produce packaging might do more harm than good. It can drive deforestation, contribute to soil degradation, and increase the use of fertilizers and pesticides, which in turn cause their own ecological damage. But don't write off bioplastics just yet. What we're seeing is the first wave of innovation, much like the early days of solar power or electric vehicles. Around the world, researchers, engineers, and entrepreneurs are pushing the limits of material science to develop smarter, more sustainable alternatives. In Indonesia, where plastic waste clogs rivers and chokes marine ecosystems, a startup called EvoWare is producing edible packaging from seaweed. Seaweed doesn't require fresh water or fertilizers to grow, and it actively absorbs carbon dioxide from the atmosphere. In Mexico, a researcher has developed bioplastic from nopal cactus juice, an abundant, drought-resistant plant that doesn't compete with food crops. The resulting material biodegrades in under a month. In Italy, scientists are turning cheese industry waste, specifically whey, into biodegradable plastics. These materials are not only more sustainable, but also leverage waste streams, creating circular economies that reuse what would otherwise be discarded. In the United States, companies like Danimer Scientific are cultivating bacteria that consume plant oils and excrete a substance called PHA polyhydroxyalcohol, which behaves like plastic but decomposes naturally in soil and water without leaving harmful residues. These next-generation materials point toward a future where packaging doesn't outlive the product it's designed to hold. But even as bioplastics improve, they remain just one piece of the climate solution puzzle. Solving the climate crisis requires innovation across every sector: energy, transportation, agriculture, construction, and manufacturing. And in each of these areas, groundbreaking technologies are being developed. In the energy sector, the shift from fossil fuels to renewables is accelerating. Wind and solar are now the cheapest sources of electricity in many parts of the world. Yet the biggest challenge remains storage: how to keep the lights on when the sun isn't shining or the wind isn't blowing. Here, new battery technologies like solid-state batteries, full batteries, and thermal salt storage are emerging as powerful tools to stabilize green energy grids. In agriculture, regenerative farming practices are being promoted as a way to restore soil health, improve biodiversity, and sequester carbon. Unlike industrial farming, which depletes soil and depends heavily on chemicals, regenerative methods use composting, crop rotation, and no-till practices to enhance natural cycles. Some farms are even experimenting with biochar, a charcoal-like substance made from plant matter that can store carbon in soil for hundreds of years. In construction, one of the most polluting industries on Earth, startups are creating green concrete using captured CO. Others are using hempcrete, a biocomposite made from hemp and lime, which is not only carbon neutral but actually carbon negative during its growth phase. Buildings are also being designed with passive energy efficiency in mind, using smart ventilation, reflective materials, and natural insulation to reduce reliance on heating and cooling systems. Meanwhile, in food and fashion, innovation is rewriting the rule book. Plant-based meats are now mainstream, and lab-grown meats are rapidly becoming viable. These alternatives dramatically reduce emissions, water use, and land consumption compared to traditional animal agriculture. In fashion, materials made from mushrooms, pineapple leaves, and recycled ocean plastic are replacing leather and polyester, while digital design tools help brands reduce overproduction. Even the air we breathe is being targeted for innovation. Companies like Climeworks in Switzerland and Carbon Engineering in Canada are developing direct air capture technology that pulls carbon dioxide straight from the atmosphere and stores it underground or repurposes it into new products. The potential is enormous, but so are the challenges. Cost remains one of the biggest obstacles. Bioplastics and other green materials often cost significantly more than their fossil-based counterparts. For consumers, that means higher prices. For businesses, it means lower margins or less competitive products. But as technology advances and demand grows, prices are slowly coming down, just as they did for solar panels and electric cars. Infrastructure is another challenge. For bioplastics to work, we need waste management systems that can identify, separate, and compost them properly. That means investments in industrial composting, public education, and clearer labeling. Right now, even well-intentioned consumers often don't know where to dispose of biodegradable packaging, and when it's mixed with conventional plastics, it can contaminate entire recycling streams. Then there's the issue of policy. Innovation moves fast, but regulation often lags behind. Many governments still subsidize fossil fuels while offering little support for sustainable materials, but things are changing. The European Union has introduced the Green Deal, aiming for net zero emissions by 2050, with strong support for circular economies. Countries like France are banning certain single-use plastics and promoting reusable packaging. In the US, individual states and cities are leading the way with bans, incentives, and new waste collection programs. But perhaps the most important factor isn't government or industry, it's us. Consumers have the power to accelerate change by choosing sustainable products, demanding better packaging, and pushing brands and policymakers to act. Every purchase we make is a vote for the kind of world we want to live in. And in that world, waste doesn't last longer than civilization itself. Instead of extracting and discarding, we regenerate. Instead of endless consumption, we prioritize smart design, reuse, and circular systems. Bioplastics may not be perfect, but they're part of a broader movement, one that's reimagining how we interact with the planet. And we're only at the beginning. As technology matures, as infrastructure evolves, and as awareness spreads, we could see a world where packaging, buildings, food, and fashion all contribute to healing the climate rather than harming it. The solutions are here. The momentum is building, and the time to act is now. Because in the fight against climate change, there is no single fix, just 1,000 breakthroughs, big and small, all moving in the same direction. Innovation isn't optional. It's our last best hope for a livable future.